Greetings and welcome to Flanagan's EcoLogic. I am your host, Ted Flanagan. And today we're talking transmission lines, highly efficient transmission lines that can move more power, ever essential in today's growing energy economy. With me is Dr. Jason Huang. He is the co-founder and CEO of TS Conductors. Jason, welcome to the podcast.
Thank you, Ted. It's a pleasure to be part of your program.
Well, I'm just delighted. I've heard so much about your company and so much about you and what you're doing. And let's cut right to the chase. You actually are building transmission lines, or some of us call them wires, but I guess more technically they're conductors that are up to can carry up to 3 times as much of electricity, and that can half the line losses. Is that right?
Yes. What it means is you can as much as triple the transmission line capacity using the existing structures in the power line corridor. And you can get the grid upgrade done with the least cost and also in the shortest amount of time if you were to deploy TS technology.
How did you come up with this idea? What brought you to this point of running this fantastic company?
Well, I did not invent the idea, but I did have something to do with commercialization. I used to be in aerospace. I worked on all the major aircraft platforms, 787, A350, F-35, F-22, F-18s. And then in 2010, I changed my career from aerospace to advanced conductors. Um, Without knowing what I was walking into. It is a very conservative industry.
Is it?
The electric power sector, and when I joined that company, I did not know what I was getting into, and I had to step up to run that company when that company went into bankruptcy and then bought by the Russians. And had to turn that company around. And eventually I did part ways from the Russians in 2017. However, during that time, I learned to appreciate the challenges associated with advanced conductor. That generation of advanced conductor had glass fiber, carbon fiber in making the composite core, and the aluminum being stranded around it. The vulnerability of a composite material is not the fibers, it's actually the polymer matrix. And they are responsible for the delicate nature that the bending failures, they're responsible for degradation associated with environmental parameters like moisture, oxidation, UVs, and ozone. These things were completely addressed, actually designed out in the TS technology platform. So when I had the opportunity to acquire TS technology in 2018, it was a no-brainer that I went all in. It is a solution that we still have the carbon fiber composite. We do not need fiberglass in there, which actually further improve the properties of the composite core. And we have this effective protection of the carbon core, more specifically, effective protection for the polymer matrix in the composite core with the aluminum encapsulation around the composite core.
Let me cut you off here because you're deep in this, and my listeners probably are thinking, wait a second, a transmission line, isn't that just a simple wire? But your technology is aluminum encased carbon core. Is that right?
The conductor
go from the center of the wire out.
Yeah.
It seems to me that you have this. Oh, go ahead. You have the carbon core.
The conductor itself, you have two elements. One is the conducting element. I should have brought a sample with me. I may have one in the closet. I'll show it to everyone. You have the conducting material, And then you need a strength member because the conductors go between the towers. So you need strength member that is strong, lightweight, and does not sag. And you need the conducting material to be economical and to have very good electrical conductivity. So what we have in TS Conductor, I would say we have the best material science had to offer today, which is why the letter T in our name. So the aluminum we use is the high purity annealed aluminum, which allows you to have the best electrical conductivity. In terms of the strength member, we use carbon fiber composite. Why carbon fiber composite? It has twice the strength of steel, 20% of the weight of steel, and virtually no thermal expansion, which allows you to basically remove thermal saggings. That combination of property is what is desired the most when you design the conductors. So
Yeah.
if you combine the two, it reflects the best material science had to offer. That's why the letter T.
Yeah.
And our conductor is used by linemen in the field for installations, for maintenance. So the letter S, which is for safety, that is also essential.
Mm.
So how do we have that S design into the product? That is through that aluminum encapsulation layer around the carbon core. And then you have the additional aluminum layer being stranded on. And that's where we have aluminum encapsulation, which is right next to the carbon composite core. And then the additional aluminum is stranded on. All the aluminums are the conductive elements.
Okay, so at the center of the wire, I'm really
Yeah.
dumbing this down. Sorry, Jason, but
Yeah.
at the center of the wire is the carbon core, and
Yes.
that is just providing the strength to the line, correct?
Yes. Yes.
And then you've got the aluminum around it that is actually carrying the power.
Yes. That's correct.
Okay, so now transmission lines have been around what since 1908 or over
Since early last century. Yes.
and like you said, the industry hadn't really advanced these wires or these conductors very much. And why is that? They're just a proven technology. It worked, so don't change it.
Well, our industry is notoriously conservative, and most utilities are monopoly by design, so they do not have to compete or innovate the way private industries do.
Yeah.
And the regulation that they have to operate under does not encourage risk taking, because supposedly the utility commissioners are protecting the consumer's interests, so they don't want the utility to take risk. And we also have, I think, the utility prerogative of emphasizing reliability and the safety. So if you have a solution that is proven to be solid,
Yeah.
it's like, what is the reason for change, right?
Yeah.
And in the past 100 years, we have relied on a conductor called ACSR, aluminum conductor, steel reinforced.
Yeah.
What that conductor has is hard aluminum combined with steel. And this was developed in 1908. The hard aluminum limits the conductor temperature limit. There's this temperature of 93 degrees centigrade. If you go above that temperature, the hard aluminum gets annealed to become a soft, low strength aluminum. And so you cannot use ACSR above that temperature. Otherwise, you run the risk of the conductor is not going to be the same anymore. And that limits capacity.
Yeah.
So there has been new conductor technologies over the years. So if you were to fast forward to the 1970s,
Yeah.
when our steel industry was able to offer stronger steel, now you are able to combine that stronger steel with so-called annealed aluminum, that allows you to go to high temperature. And with going to the high temperature, you can get to the higher capacity.
Yeah.
The challenge is steel expands when hot. So you have massive sagging problem.
Yeah.
Even though you can get high capacity, but it is saggy. So you have to have taller towers. You got to shorten the span distance between the towers, which makes the project more expensive.
And
So,
I live in Southern California,
yeah,
and during extreme heat waves, we have to de-energize or derate our transmission lines, right? Because of this issue.
because of sagging.
It's
And they may have conductors that are ACSS, which is the high temperature conductor, but most of the conductors may be ACSR, which is the 100-plus-year-old technology. So what happens when you have ambient temperature being high is you cannot put as much power there because the conductor, it is sagging, it is approaching that clearance limit.
Yes.
So you have to derate it to address the sag, and that limits your flow.
Just at the time that you need the power the most,
That's
because of
exactly
air
the challenge.
conditioning. That is when we have to. So now let's talk again. I know I'm very elementary with this topic, and but I'm imagining a large transmission tower, and I'm
Yeah.
imagining that it's got three lines or three conductors.
Yes.
Is that I
Three
trust
phases.
that's because of three phases, right? But now I've always thought, and I'm a commissioner for Glendale Water and Power, and we have a tremendous transmission capacity constraints coming into the Los Angeles area and coming into Glendale in particular. I thought you could not run more power through those lines because of how far apart they are from one another. Is that not an issue?
Well, the spacing between the phase wires had to do with wind. That when a wind blows, the conductor would swing. You
Yeah.
wanted to avoid the clash. That's why you keep the phase wires separate from each other, or having enough separation so that when the wire starts to swing because of wind, they're not going to clash. Because when you have clash, you're going to have shorts in the circuit.
So you can actually take the same wires, let's say you've already got them spaced properly, and you can actually, by putting in the TS conductors, you can just be running more power, but maintain that same spacing. Is that right?
Yes, you are able to leverage the existing configuration, the existing structure, could be power towers, could be poles
Yeah.
in that corridor, and get 3 times capacity by running TS conductor instead of most likely the traditional ACSR conductor.
Yeah.
The reason for that is, one, we can put a larger TS conductor on that does not violate the sag clearance requirement, and it does not impose higher tension to the cross arms. Because if you have
Yeah.
a greater sag that you have to address, then you have to raise the tower height,
Yeah.
which makes it more expensive, or you have a much higher tension load to the wires, to the conductors, then you have to strengthen the cross arm. We can avoid doing any retrofit, and by going to a larger conductor and be able to leverage the TS technology, for example, low emissivity service and dynamic line ratings, you are able to get the 3 times capacity.
Are there instances that you can't do this, Jason? I mean, I'm thinking about, we have a big transmission corridor from the Intermountain Power Plant up in Utah coming down to the LA area, and I think it carries 2,400 megawatts, if I'm not mistaken. Can we actually triple that capacity?
Yeah, if let's say you don't have wind that helps you, you may not be able to get to the 3x, or there are certain conditions. For example, dynamic line rating leverages when you have strong wind, that's going to create a better cooling effect. So it depends. But with TS technology, you can always get a minimum of 2 times, and sometimes you can get to 3x.
Really? So are there any instances that you cannot put your technology in place on a transmission line where you cannot retrofit for any reason?
We have not seen that unless the towers are so old that you don't do retrofit of the, well, it's not retrofit. You don't do reconductorings, you would just do rebuild. And in that case, when you do rebuild, we help the utility to do it at a lower cost as well, because when you rebuild, you can do it with fewer and shorter towers or poles, so
Yeah.
that the overall project cost is actually less, even though you're using the latest conductor technology.
Isn't that fantastic? A real win-win. And we were talking before we started recording, we were talking about the booming demand for AI centers. And I guess it's not just AI. We've got building electrification going on. We've got more and more e-mobility going on, people shifting to electric vehicles. There's just a huge need for more power in the United States and probably all over the world. You must be addressing that.
Yeah, you're looking at load growth uh, today, especially driven by data centers and AI. And we're just scratching the surface in terms of AI deployment.
Yeah.
How many of us use AI today, and how often do we use it? Wait until you have everybody using AI for all the applications. The need for electricity just to power AI, the data center, is going to be immersed.
Yeah.
And on top of that, you mentioned about electrification of everything,
Yeah.
that we're doing energy transitions, and we have to do that. It's out of necessity. I learned somebody speaking about a week ago that there is no planet B or plan B.
Yeah.
This is it. So we have to take care of it ourselves and leave a better future for our future generations.
Yeah.
And that task is today, that we got to get our grid upgraded, because the power flows through the power lines, and the power lines are the conductors that the electron passes through. And by and large, we're still relying on the technology that was developed about 120 years ago, which is insane when you think about it.
Yes. Yeah, it is. It is. So let's talk cost. I mean, you talked about rebuilding lines and actually rebuilding cheaper than you would have in using conventional transmission lines. Again, I'm dumbing this way down, but I was doing a little bit of research. It sounds like transmission lines are typically what, $4, $5, $6 million a mile? Is that right?
It depends on the voltage. I would say if it's 230 kV, 345 kV, you're probably looking at $2 to $3 million a mile. And if you are looking at the supergrid Texas is building, 765 kV, it might be in that range that you're referring to. So
Yeah.
they are pretty expensive. I think the money side is one aspect. The
Yeah.
bigger challenge is actually about getting the permits for building new lines. It's becoming virtually impossible. You have to wait for a dozen years to
Yeah.
get all the permits in place to allow you to build it. So the better way is actually looking at the system that we currently have and upgrade that by reconductoring.
Yeah.
So what does it mean, reconductoring? Well, you just change out the conductors that reconduct, right?
Yeah.
That allows you to leverage technologies like TS and get 2 times or 3 times capacity from that existing corridor that's already in place.
And is there a permitting process for that?
Well, if you don't need any retrofit,
Yeah.
I don't think you even need permit. But if you do retrofit when you do reconductoring, some technologies do require that. Like, for example, the technology I mentioned about ACSS, that was the high temperature, high sag uh, uh, conductor.
Yeah.
Yes, you do get higher capacity, but you have to address that excessive sagging at high temperature. and you have to raise the tower height, and it will be more expensive. And I'll give you an example. In 2021, we did a project in North Dakota. The utility is Montana Dakota utility,
Yep.
and they have several wind farms that they needed to accommodate. It's a 230 kV line. They did the initial project, reconductoring project, with ACSS technology, and they were replacing or retrofitting 90% structures because of the excessive sagging. When they switched to TS Conductor for the last 11 miles, we were able to allow them to get the reconductoring done without any retrofit. And they saved about 40% in project capex, as well as about 12 months in the planned project schedule. And that's what TS can do in terms of reconductoring, that you get it done with the least cost and also the shortest amount of time while meeting the capacity objectives.
You have a negative marginal cost. As our friend Amory Lovins, who we were talking about, your advisor, would like to say, a negative marginal cost. So are you fully patented, or is this technology, do you have competitors that are jumping on this bandwagon?
Yeah, TS technology is patented. However, we do have multiple manufacturing options. We have conductor manufacturers around the world that they leverage the encapsulated core technology from TS. So they will be also in a position to offer conductors, in addition to conductors made by TS. We make the TS conductors in America. We have two facilities. One is in California. The other one, it will be in productions Q1 of next year. We're talking about 6 months away. Very excited about it. It's in Hartwell, South Carolina.
Yeah, yeah. And so you're just, you must have people calling you up every day.
We do. At the same time, I would urge more and more utility professionals to take a hard look of TS technology. And I did have a TED talk on the topic that it's a short 10-minute talk. The point is, we offer a better value in terms of transmission capacity per dollar amount. And we can get it done in a very short time in terms of getting capacities doubled or even tripled. And we get it done at the lowest possible cost, even comparing to the traditional conductor options. That's important for people to remember. And do it with safety at heart as well.
So what are the naysayers saying, Jason?
Well, there are people that in our industry that they are always conservative. They would say, well, let utility A try it for 10, 20 years, and then we will do it. I don't know whether we have luxury for that type of approach anymore. And the bottom line is, when you make the decision on conductors, it's a 50-year or longer time horizon impact. Because if you elect to use the traditional conductor like ACSR, you're going to be stuck with it for another 50 years.
Yeah.
But if you pick TS today, you're going to benefit from the TS values, including 2 to 3 times capacity, including 50% reduction in line loss, including low maintenance for the next 50 plus years as well. So it's a very consequential decision.
Yeah. Which regions of the United States are you targeting? You mentioned you have manufacturing in California and soon to have manufacturing in South Carolina. Where are the hot spots in your views?
Yeah, our conductor can be deployed in all of the geography and environmental conditions. For example, we have significant deployment in Arizona. All the Arizona utilities are TS customers. That's in the Southwest, hot, dry.
Yeah.
And then you can go to north, like North Dakota, for example, which is very cold with a lot of ice. That we have both reconductoring projects as well as new transmission lines built with TS Conductor. Why they select TS Conductor for new lines as well? Because we offer lower cost compared to the traditional conductor option. And in the southeast, we have Florida. We have Nextera Florida. And by the way, Nextera is also an investor of TS.
Yeah.
In northern part, we're going to have Dominion being TS customer as well. And in the middle of the country, we have customers like Tennessee Valley authorities as well. So it can be used in all the locations. We can deal with heavy ice. We can deal with hurricane winds along the coast. We can deal with the extreme heat in the south
Yeah.
and corrosive environments near the coast. This is a conductor that is well designed.
Yeah.
It can be used for distribution voltage as well. So if you take the letter T and S, it could be a total solution as well.
Yeah. Well, I want to talk about distribution because, when I heard about your company some years ago, I guess a couple years back, I only heard about it in terms of transmission, but there are so many overloaded. Here I'm in New York right now, and as I told you earlier, and boy, oh boy, you can just see a lot of the distribution lines around here are completely overloaded. I guess they were originally designed before people had air conditioning, certainly before there was a lot of electrical appliances in the homes. And so these wires are certainly, or the conductors, excuse me, are certainly not just limited to transmission. How small can they get? I mean, is it only down to 4 kV, or do you go even below that?
Yeah. The distributions, we look at anything that's below 69 kV, that would be a distribution voltage circuit.
Yeah.
And some of the distribution lines, they actually use pretty large conductors. But
Yeah.
the challenge with distribution is when you use smaller conductor for certain distribution lines, the challenge is, will the conductor work with linemen that in the distribution sector, they are normally the apprentice, less skilled. Equipment are also less sophisticated. So the
Mhm.
challenge is, will the advanced conductor, which allows you to go to high temperature, allows you to address the sag issue. That's the definition of advanced conductor, where you're using composites to replace steel to manage the thermal sag. The key is, will the lineman be able to embrace your conductor? Will the conductor be robust enough for the line crew? And do you expect perfection from line crew? And that's where TS uniquely solved all those problems by leveraging the aluminum encapsulation protection for the carbon core. And if you were to use other advanced conductors, which has been around for about 20 to 30 years, those products were too delicate, difficult to work with, easy to break. And this is why when you asked, why aren't people calling us every hour, every day? And one of the challenges we have to deal with is we're often lumped with the first generation of advanced conductors that, oh, well, we know your product, but they haven't even had a chance to talk to us. It's all perceptions.
And
And when you
I
are
think
in a risk averse
right.
industry,
Yeah.
people have perceptions, and that's one of the challenges we have to address.
I think I saw in one of your videos on your website that you were talking about how your conductor can bend and come back to a straight mode. Uh, and I'm gathering that that's not the case with some of the other earlier conductors, that you might bend them and damage them and never really be able to get them back to their full capacity.
Yeah, the problem is safety and reliability of transmission and the distribution lines are critical, are essential.
Yeah.
So if your product cannot deal with bending, you have a serious issue. That's part of what we call workability. So when you talk about
Yeah.
conductors, especially new conductor technology, I often refer to the triangle, that one corner is about performance. How
Yeah.
much more capacity can you deliver? The second corner in the triangle is about affordability. Is it more economical compared to all the options?
Yeah.
And the third one is workability of the product in the field. Will the lineman be able to embrace it? Is it difficult to work with? Or can you use conventional tools, equipment, methodology, and training for your conductor? We check all those three boxes.
Yeah. Yeah.
But I cannot say that for the other stuff.
Right. Oh, that's incredible. So you must just be scratching the surface of the potential in the United States. And of course, this conversation could go global quite easily. But how many thousands of miles of transmission lines are there in the United States? And is that in the hundreds of thousands of miles?
Yeah, you look at transmissions alone, it is probably about 700,000 circuit miles. The circuit mile means you just measure the length of the circuit, right? And
Yeah.
then each circuit, you're talking about three phases for sure.
Yeah.
Higher voltage, you have bundles in each phase. So you multiply that by 3 and multiply that further by the number of bundle conductors. That's how many miles of conductor you have in transmission. In distribution, the rule of thumb is you multiply that by 10. So we have about 6 million circuit miles of distribution line. And again, you multiply that by 3, that's the number of conductor lengths. But this is just for the existing grid size. That is not adequate, and we will have to do some new lines in addition to reconductoring. So this is a massive market. And obviously, the solution like TS, it is not only just good for US, it's good for the global market. We can help developing countries in the grid transformation process, and we can also, help the advanced economies to deal with the surging load growth from AI and data center that we're dealing with today.
Jason, this has been a fascinating conversation. I apologize for my very pedestrian questions, but this is a fascinating topic, and I really appreciate your being on the podcast. And congratulations on your factory in California, your new factory coming online in South Carolina, and just how you're contributing to this huge demand for electricity and all of the benefits that it brings. So thanks so much for being on the podcast.
Ted, we really appreciate to be part of your program. This is a technology that is blessed by utility companies. We're invested by National Grid, NextEra, Edison International, and Quanta. Quanta is the lineman company, and for them to invest in TS, it means a lot. And we appreciate the opportunity to participate and to be in a position to make a difference in energy transition, as well as in addressing the need from AI and data center to allow US to be competitive in this AI race, which is so important.
Must feel good. It must feel good what you're doing. Great stuff.
Yeah, thank you very much. I would make a point about if anyone wanted to join TS, this is a great opportunity. The reason being, you can feel good while making money, and there are not that many jobs that gives you satisfaction that you are making a difference for the world and for humanity as well.
Congratulations again. Appreciate your being on the podcast.
Thank you, Ted.
That's it. Thanks for listening to Flanagan's EcoLogic. We'll see you next time.